Hello everyone, my name is Tuhin. Today I have come up on a new video on LangGraph. This is the third video in this series, and here we'll discuss and demonstrate on building conditional edges and feedback loop. We'll be seeing how to create graph with conditional edges and creating graph with the feedback loop, and feedback loop is another type of graph with the conditional edges. And finally, we'll see our demonstrations on code how to build a project with conditional edges and using feedback loop. So we have already learned on LangGraph edges. So LangGraph edges is a directed connection between two nodes, and which means that information can flow from node A to node B, and it is denoted as, first we need to add the nodes and we need to give them a name. Say for we have created a function for node A and node B, and we need to add give them a name and add that node in the graph, and finally we need to create an edge between node A and node B. So this is how it looks like. Now we learned about how the edge looks like. Now LangGraph has a very interesting concept like conditional edge. So in LangGraph, a conditional edge is a mechanism that allows a graph to dynamically choose the next node in the runtime on output of a previous node. So from the start node, based on some particular condition, it can go to the either add node and subtraction node. So it is denoted as, first we need to add the nodes in the graph, similar we have done for normal edges, and then we need to add a conditional edge, and conditional edge takes three parameters. One is that we need to define the start node, that is the start node, and decision logic for the next node. Decision logic for the next node is a function which will decide how to move to the next node, and finally the next node definitions we need to give, and here it will come as a key value pair of edge and node. So first we need to give the addition operation, this is the edge, and the corresponding node where it will finally go, and for the subtraction operation it will go to the subtraction node. Okay, so let's see it in action. So I have already created a project. If you don't know how to create a project using poetry, you can see my another video. And so we used poetry in it to initialize a particular project, and I used Python 3.12.4. So you can use the same version if you want to build that particular project along with me. So now the project has been created. I have already opened that particular project in PyCharm. Now let's go inside the project and install LangGraph. So in order to install LangGraph, we need to run poetry add LangGraph. So LangGraph has been already installed. Now let's go to the project and we will build some particular project structure, and there we will add few Python files. So as you see, the once I have added the LangGraph has been added in the dependencies, and now let's create that particular project structure. We'll add a directory called source, and inside the source I will create another directory for conditional edge, and inside the directory I'll create few Python files. First is we will need to have some schema, so I'll give it a name like schema.py, And then I will create another Python file where I will define the nodes, and I'll give it a name as nodes.py. And finally I'll create a file for creating the graphs, so along with nodes and edges. So I will give it a name as graph. And next I'll create a main file from where I will call that graph. Okay, now inside the schema I will add the particular class for storing the state of the graph. So let me resolve the dependency first. So I have defined a class called agent state, um, with as typed dictionary, and it has four properties called number one, number two, and final number, and an operation. So number one and number two will be taken as input, and final number, it will be the output from the number one and number two based on the given operation. So operations can be, say, for plus, addition, subtraction, multiplication, and based on that it will take two numbers, and finally it will add that, in the it add, subtract, or multiply in the final number and store it here. So now we'll see how the nodes look like. So here we are trying to build a conditional edges. We have already seen building normal edges and not with the normal nodes. And if you did not see that particular video, you can see the episode 2 in this series. Now I'll define the nodes. Okay, so I have created four different nodes. One is adder, subtractor, multiplier. So adder will take it will take two, number one and number two, and finally add them and store them in the final number. Similar to that, subtractor will be subtracting between number one and number two, and we will store the final value in the final number. And multiplications will do the multiplications between number one and number two, and finally store that final value inside the final number state variable. And decide next node. This is the important part, where this is the decision logic, that how the routing decisions will be taken. Like, say, for based on this condition, say, for if operation is given, operation is another state variable, operation is given as plus, then it will return addition operation, and operation is minus, then it will return subtraction operation, and otherwise it will take the multiplication operation. Now we'll finally make the graph, and there I'll explain how we will be using this particular method inside in while building the conditional graph, the conditional edges. So let's go to the graph. The conditional as agent state. So this has been installed. Now I need to import the adder node. So I have imported subtractor node that I have already defined inside nodes.py, and multiplier node. So, and start is a predefined LangGraph node which defines the start of that particular graph. So I am again importing the start, and this decide next node, that decision logic that I have also defined inside the nodes. Now let's see how it is working. So I have defined a graph, and defining a graph works like that. It's a state graph. It comes from the LangGraph library, and we need to define that particular agent state that we already created inside the schema.py. And then I added all the nodes that I have created: add node, subtraction node, multiply node, and added another node called router, which nothing but takes a state and as an input, and generates another state. It's just a router takes a state as an node as an input, and another node as an output. Okay, now I'll add an edge where it will from the start to the router, so this particular node, and now we'll build the conditional edges. Okay, now how the conditional edges will look, let's go back to the demo video here. uh, Now here, if you check the router, based on that condition, that is addition operation, multiplication operation, and subtraction operation, it will move to the node. So from the router, we are using some particular decision logic. Based on that particular logic, dynamically at the runtime, it will decide which node to move. So adding conditional edges takes three parameters. One is the start node, that is the router, from where the it will move to the different nodes. Now the decision logic that we have written inside the decide next node. So here we have written, so based on that plus sign operations, we will be moving to the which particular direction. Okay, now next move to the finally edges versus node key value pair. Now addition operations will lead to add node, subtraction operations will lead to subtraction node, multiplication operations will lead to multiply node. And now finally we will be adding edges that add node, subtraction node, multiply node, and we add them with the end edges. End node is nothing but again a predefined node that is given by the LangGraph library. So I'll be importing this name, so it's available in LangGraph constants, so start and end. Now finally we compiled that LangGraph. Okay, now I'll add few code in the main so that we can see it, that how this is being executed. Now let me show you this particular up to this particular code is responsible for generating the graph, visual graph, which we'll get to see inside the output folder. And now finally we are invoking that um, particular app with the operation plus. So when we use the operation plus, then it will take the addition path, and it will store, and finally it will print the final number. And when we do the minus, then it will do the subtraction. And when we give the multiplications, we have three operations available. Give the multiplications, it will multiply between these two numbers. Okay, now let's say it in we need to create another directory called output. So it will, inside that it will store the visual graph. Now let's run the main. So as you have seen, it has added 11 and 33 and generated 44. And interestingly, you will see the graph has been generated. So from the router, we have taken the different route, that is to add node, multiply node, and subtraction node. And each of the node then finally connected to the end node that we have defined in the graph.py section, and it has been generated. And as we have called the operation plus, so it has generated 44. Let's use minus and see what happens. And if we run main, it is minus 22, that is 11 minus 33. And so it took this subtraction root and ended. Okay, and then finally if we give multiplication, then it will multiply these two numbers and generates 363. 11 cross 33 is 363. And if you go to the graph again, it took this particular path, directly this part. So router, multiplication operation, multiply node, and finally it ended. Okay, So we have seen here how to create a conditional graph. Another variation of conditional graph is feedback loop in LangGraph. So feedback loop is very important concept. We'll see where the feedback loop is basically used, and these two important concepts using conditional edges and feedback loop will be very instrumental in creating final AI based agent and using the React agent in LangGraph. So now let's see some theory for the feedback loop. So what is a feedback loop? A feedback loop usually means a graph that can self-evaluate, improve, adjust its future outputs based on results from prior executions. So you can think of it as a LLM workflow with the ability to learn within the session. So if it makes a mistake, it will learn from that particular mistake, or even it will improve the existing output, continuously iterate, and then finally generate a response with a given condition. So LangGraph gives a fine balance where the developer can control that when that particular loop should end. It does not give entire control to the agent. So it's a fine balance between what agent can perform and what developer is intending to do. So this so you can simply think of like you can draft, evaluate, again revise. So revise again, it's come back and reevaluate again, it comes back this particular loop and approve. So for the demo purpose we'll building a weather feedback loop, and we'll create a very interesting demo for the uh, for the demonstration purpose of the LangGraph feedback loop. So let's see it in demo. We have already created a project. We will create another directory inside that inside the project itself. We'll call it a feedback loop, and we'll create another similar set of files and directories. So first I'll create few files called schema. So I'll use a different schema because for that demonstration purpose. And let's create another file called nodes, and then create another file called graph, and finally let's create another file called main, from where we'll run that particular demo. And also I'll create a directory called output, where we will create the visual graph for the feedback loop. Okay. Now, so we'll start with the schema.py, where I will define the agent state. Agent state is a class where agent will be storing its state across the execution for all the nodes. Okay. So schema, I have added a few fields called name, weathers, and counter. So name, it will just used for grading purpose. Weather, it will take different kind of inputs and it will store it in a list. It's like sunny, rainy, or cloudy. So our intention will be, if it is sunny or cloudy, we'll continue playing, and if it is rainy or if we have played too much, then we will exit and go back home. Okay. Now let's define the nodes. So we have a greeting node, we have a weather node. So weather node is something like it will ask users what is the weather, and based on that it will add that particular weather in the weather's list inside the state, inside the agent state, and it will finally return the state. And then similar to the logic that we have seen in the conditional edges demonstration, it will have another logic whether it will define whether to continue or exit. Okay, so it is a should continue logic, and if it is supposed to continue, then it will continue. It will check whether we have played 5 times or it is rainy. So in either of the condition, it will exit. So if it is 5 times or if it is rainy, it will exit. If it does not satisfy both of the conditions, then it will continue playing. So it will say let's play. Uh, and if it is rainy, it will say it's raining, let's go home. Or we have played, if it's more than 5, then counter is more than 5, then we'll say it like we played a lot, let's go home. So we have defined the node. Now finally we'll build the graph. So building the graph is very similar to what we have done for the conditional edges. And end is a predefined LangGraph node. Okay, so I have imported all the required files, and then let's build the main. So before going to the main, I'll explain it a little bit. So it is again a conditional edge, as I have already explained. Feedback loop is nothing but a conditional edge where instead of going to the another node, it will go back to the previous node. Okay, based on the condition. So we have the source node is the weather node, and then the decision logic where to go next. And if it is a loop, then it goes to the weather node, and if it is exit, and it goes to the end node. Now loop and exit condition, if you check and look back, you will see it here. We have exit and we have loop. So if it is less than 5 numbers, or weather is not rainy, then it will continuously loop. Or if it is other than this, more than 5 times we have played, then it will exit. Or if it is raining, it will exit. Okay, now let's go back to the main and demo, and these particular portions will be responsible for generating the visual graph, and which will be added inside the output directory. And here we have inside that agent state, we have 3 different uh, fields that are name, weathers, and counter. So we have initialized it with a name to in. Weather we have taken an empty list, and counter we have initialized with -1. So why -1? Because the first time it will be increment every time inside the loop, it will be incremented, and so it will check if it is more than 5, the loop will end. Or if it is the weather is rainy, then the loop will end and exit. Okay, now let's see it in demo. So it is asking, hi there to him, and what is the weather? I will say it's sunny. So agent is saying weather is sunny, let's play. Now what is the weather? I would say cloudy. Now weather is cloudy, let's play. Now if I call it sunny again, it will say let's play. If I again call sunny again, it will say let's play. If I again call sunny, now it's telling it's a 5 time the loop has been executed. Now it will break the loop, and it will say that we played a lot, and let's go home. And it is finally saved that graph. It has created that particular graph with the feedback loop. So from the weather node is the starting node, and based on the condition, it is exiting or that particular graph and going to the end node, or it is looping and coming back to the same node, the weather node only. That's how it is creating a feedback loop. Now let's see the another conditions where it will go rainy, and it will also exit. Okay, cloudy. So weather is cloudy, let's play. Now sunny, weather is sunny, let's play. And weather is rainy, I'm giving rainy, it's raining, let's go home. So it broke the loop, and Finally it's exited from that feedback loop and it came here. Okay. In the next episodes, we will be learning LangGraph AI agent, LangGraph AI agent with the memory, and finally we'll be building React agent and using Lang's myth for tracing. So stay tuned. Next videos are going to be very interesting. So please visit my channel, and if you like my video, then please like, comment, share, and subscribe. Thank you.